Hello, this is Miss Brown, and this is going to be a screencast of Biochemistry for Biologists Part 2. And keep in mind, as you're taking your notes, you can stop and rewind if you need to. So first, let's start talking about compounds. And compounds are atoms that are chemically bonded together, and they lose their individual properties in a compound. And something very common here that you know about is salt, table salt. We've all used it and eaten it. And of course, it's sodium and chloride put together. And sodium is a metal. It's shiny. It's silver if it's in its pure form. And it's very reactive, and chlorine is a green gas. And they're both very dangerous alone. But put them together and we eat it, all the time, every day. And it's actually needed. You need some salt in your diet. So here are some formulas I want you to write down that you'll be responsible for. You don't have to memorize them, but you should be able to recognize them. And they're hard to type in here, so I'll help you here. This one's H2O, right? That's water. And of course, the 2 is a subscript. That means 2 H's for every 1 O, oxygen. So that one's water. The next one, NaCl, that's sodium chloride, which is table salt. Then we have CO2, that's carbon dioxide. HCl, hydrochloric acid. C6H12O6, that's glucose. And you know what that is. If you know someone who's a diabetic, you ever heard about their glucose level, your blood sugar level. Okay, next slide. C12H22O11. That's sucrose. That's table sugar, like what you put on your cereal or put on strawberries or put in your coffee. C27H45OH. That's almost a mouthful. That's cholesterol. You may have heard your parents talk about that. A lot of times as we get older, we have to worry about our cholesterol levels in our blood. And wow, look at this one. C2954H 4664 O832 N812 S8 and Fe4. That is hemoglobin. And because of the iron in this is found in your blood. It carries oxygen in your blood, and it's made of iron. So the iron is actually a reddish metal, and it's what makes your blood red. All right, so a molecule is the smallest amount of a compound, like a molecule of water. It can't get any smaller than that, because if it did, it wouldn't be water anymore. And glucose, if you take one molecule out of glucose, you don't have that same sugar anymore. You have something else. If you take one atom out of the molecule, I should say. All right, so a chemical bond is a force of attraction between atoms in a compound, and it's what holds holds atoms together to make sugar and cholesterol and hemoglobin and water. It's this bond, this attraction. And what is involved in that? That's the electrons we find in the outer level. You probably learned in 8th grade those are called valence electrons. Valence means the outside level or outside of something. So that's your valence, your outside electrons. Here's a carbon model, and of course our outside electrons are these in this outer energy level. It has 4 out here. So there's 3 ways they can form bonds. They can lose electrons, gain electrons, or share electrons. So they either form as a result of a loss or gain of electrons or sharing these electrons. So that's the 3 ways: lose, gain, or share. Okay, there's going to be 3 types of bonds. The first one we're going to talk about is ionic bond, and it results from the loss or gain of electrons. And an example of that is salt, NaCl. It's usually a weak bond, and it will break in water. Of course, you know about salt water. Also, salt, maybe when you season food like your soup or something like that. And here we see what happens. Here we have a sodium. They had one extra one out here and it wanted to get rid of it. And here we have chlorine that tends to gain electrons. So when you put these 2 together near each other, they will bond immediately and make sodium chloride. The second type of bond is a covalent bond, and it results from sharing. And you remember that by co-chairman, co-captain, cooperate, share. Covalent means to share, and it's usually a very strong bond. And here we have carbon, and it's going to bond to each of these hydrogen atoms because the 4 will join in with it. And you get this, CH4, which is methane. All right, here's some molecular trivia. This is the empirical formula we've been talking about. And of course, that's glucose. And here's the structural formula. If you take chemistry with Mr. McCandless, you'll do several of these in his class. There's also diatomic molecules like hydrogen. It will be found bonded with itself, sharing electrons, and same thing with oxygen. And here's a covalent. Here's what to remember. They share a pair usually. And because these electrons are zipping around both all the time, it just makes it much stronger. So covalent bonds can be nonpolar or they can be polar. Nonpolar, they share electrons equally like carbon dioxide, but polar shares them unequally. And the most famous, I guess, or most common of these is water. And our study of water, we'll talk about that a little bit more. So here you can make a graph in your notes to tell the differences between ionic and covalent bonds. So ionic is loss or gain, covalent's a share. Ionic has different electronegativities. That means the charge is different. Covalent has similar electronegativities. Ionic formed from ions. Covalent, there's no ions involved. Ionic's weak, covalent strong. Ionic conducts electricity, covalent does not. Ionic will dissolve in water, and covalent will stay as the molecules in the water. And the third type of bond is a hydrogen bond. It's very weak. It's what's found between two polar molecules like water, and it's what's responsible for a belly buster. It's that slight little bond found between water molecules on the surface of water or the pool or the lake when you jump in that can cause you a little bit of distress there when you break through that bond. Now, chemical reactions. This is when you form or break chemical bonds. And they combine to form the products. Product is what you end up with, just like in math. And here's an example of some. You don't have to write these down, but here we have salt coming together to make sodium chloride. Here we have carbon and oxygen coming together to make carbon dioxide. And we have water breaking down to hydrogen and oxygen. Remember, these little numbers that apply here are subscripts. This number here in front is a coefficient. Reactants are on the left, products are on the right. So here's 4 things I want you to write down about chemical equations. They summarize chemical reactions. Gosh, think if you had to write all that out every time. They show reactants in front of the arrow. They show the products at the end of the arrow, and they need to be balanced. And I know you balanced equations somewhere along the way, I'm pretty sure, with Miss Rushing. And that's where you change the coefficients, but you never, ever, ever change the subscript. Now, notice this says recognize. Okay, so let's write down the one for photosynthesis. 6 carbon dioxides plus 6 water yields glucose plus oxygen. And then cell respiration, which is the opposite of photosynthesis, has glucose plus 6 oxygen yields 6 carbon dioxide plus 6 water. Now, are they balanced? And I'll tell you now they are balanced. Did I ask you to memorize these? No. You just have to recognize them. Notice photosynthesis brings together carbon dioxide and water, and it forms food, which is sugar and oxygen. Cellular respiration is exactly the opposite. It's how you burn that food. You take glucose, you mix it with oxygen, and you produce carbon dioxide in your breath, and you also produce water vapor. Okay, and we will stop there.